All right, this last section is also on the no calculator part of our test. So all of this inverse trig evaluating. Remember, if it's an inverse trig problem, the goal is to find theta. So which theta makes this trig function equal to this number? And remember that arcsine and arctangent are restricted to only giving angles between negative pi over 2 and pi over 2. So we're not using like 11 pi over 6. We're calling this negative pi over 6. And so that's arctangent, arcsine. And arc cosine is restricted to the top half of the circle. And so we'll only be giving angles in quadrants 1 and 2. So this is for arc cosine. All right, so the first one, what angle makes sine equal to negative radical 3 over 2? So instead of pi over 3, it should be negative pi over 3. Because sine is positive radical 3 over 2 at pi over 3. So it's going to be negative in quadrant 4. Arctangent of 1. This is one we use a lot in calculus, so this is a good one just to know. What angle makes tangent equal to 1? Pi over 4. What angle makes cosine equal to 0? So that's at the top. Oh, no, I'm sorry. Yeah, that's at the top of the circle. If you write the ordered pair correctly, it's at the top of the circle. The x-coordinate is 0 at pi over 2. If you have a reciprocal function, I like to rewrite it. So this is arcsecant is the same as saying arc cosine. Instead of negative 2, use the reciprocal of negative 1/2. So what angle makes cosine equal to negative 1/2? So if cosine's negative, we're talking about quadrant 2 versus quadrant 1. And the angle that makes it 1/2 is the pi over 3 angle. So that's 2 pi over 3. We can do that same thing with arcsine and arctangent, by the way. If we're looking at arcsine or arctangent of a positive number, we're in quadrant 1. If the number is negative, it's quadrant 2. If arc cosecant is radical 2, you can switch this around if you want, although if radical 2 is involved, we know it's either pi over 4 or negative pi over 4. This is positive, though. Sine is positive in quadrant 1, so pi over 4. Arctangent, so which angle has its tangent y over x as radical 3 over 1? So my answer is going to be negative because I'm down. This is negative. I'm down in quadrant 4. The question is it pi over 6 or pi over 3? So remember, the pi over 6 angle has the radical 3 on the x and the 1 on the y. And so we need the other angle, pi over 3. Pi over 3 is the one that's switched. So it's 1/2 for the x and radical 3 over 2 for the y. So this is negative pi over 3. Arc cosine of negative 1/2. So when is cosine equal to negative 1/2? You've got to be in quadrant 2 if it's negative. And the angle that makes cosine 1/2 is pi over 3. The angle that makes secant 2 radical 3 over 3 negative, you can rewrite this if you want. This is the flipped and rationalized version of radical 3 over 2 negative. So again, my answer is in quadrant 2 if it's arc cosine and it's negative, and that's going to be 5 pi over 6. Which angle makes cosine equal to 1? That's 0. And then these composition problems, work on the inside first, and you might want to remind yourself whether you're finding an angle or a trig value. So if it's arc or inverse, I'm finding an angle first. So this is going to be the sign of what angle makes cosine equal to negative 1/2. We just did this one, right? Number 19. We said that was pi over 3. Oh no, negative 1/2. Sorry, this should have been 2 pi over 3 for 19. So this should be 2 pi over 3 for what angle makes arc cosine equal to negative 1/2. And then what is the sign of 2 pi over 3? So this is now a speed quiz question. It's the y coordinate on the unit circle at that point. So that's radical 3 over 2. And then going the opposite way, on the inside now, this is a speed quiz question. What's the y value at 3 pi over 2? So this problem is going to be arctangent of what is the y value at 3 pi over 2? -1. And then what's the arctangent of -1? Negative pi over 4. It seems like inverse cosine and cosine ought to be able to cancel out, and usually they can, except 4 pi over 3 is not in the domain of arc cosine. So it's best on these composition problems to just still work on the inside and then the outside, even if they match up. So inverse cosine of, what is the x coordinate at 4 pi over 3? So the x coordinate is -1/2 at 4 pi over 3. That's the speed quiz question. And then what is the inverse cosine? What angle makes cosine -1/2? So it's not 4 pi over 3, because remember, we're only restricted to the top half of the circle. So the other angle that makes cosine equal to -1/2 is 2 pi over 3. And that keeps popping up, right? We had that in 22, we had that in 19. Okay, what angle makes sine equal to 1? That's pi over 2. And then it's the tangent of pi over 2. And we know from graphing and just from speed quizzes that tangent of pi over 2 is no solution. That's another one that we use a lot in calculus, so it's a good one just to kind of have memorized as well. Arctangent of -1, we're looking for the angle that makes tangent -1. So this is going to be the cosine of negative pi over 4. And the x coordinate at pi over 4, at negative pi over 4, is positive radical 2 over 2, because cosine is positive in the fourth quadrant. And our final one, what's the x coordinate at 2 pi over 3? So that's going to be -1/2. And then what's the arc sine? What angle makes sine equal to -1/2? Negative pi over 6. These do take a lot of practice to get the hang of, like, whether you're talking about thinking of an angle or thinking of a trig value. And I went through those kind of quickly. So if you need more work for them, you can always draw your little half circle for evaluating inverse trig, and then use your unit circle to do the speed quiz question.